Two nations are building rockets for the same mission: land humans on the moon, control the South Pole, and claim water ice worth trillions of dollars. NASA says 2027. China says 2030. Whoever gets there first doesn't just win a race. They write the rules for the entire solar system. For the first time in over 50 years, humanity is returning to the moon. This is the new moon race. Who's going to win? Let's start with NASA's Artemis program. Named after Apollo's twin sister in Greek mythology, Artemis represents America's return to the moon after decades away. The program officially launched in 2017 with one clear goal: land the first woman and first person of color on the lunar surface. But it's evolved into something much bigger: a permanent presence, a stepping stone to Mars, and a demonstration of American space leadership in the 21st century. On the other side, China's lunar program has been methodically building momentum for over 2 decades. From their first lunar orbiter in 2007 to the historic Chang'e 4 landing on the far side of the moon in 2019, China has proven they can execute complex missions that no other nation has attempted. Their crewed lunar program, announced officially in 2023, aims to land 2 taikonauts on the moon by 2030. Both programs share the same target: the lunar South Pole. Both need the same resource: water ice. And both understand the same truth: the nation that establishes a permanent lunar presence first will shape space exploration for generations to come. NASA's Artemis architecture is built on 3 major components. First, the Space Launch System, or SLS. This is the most powerful rocket NASA has ever built, standing 322 feet tall and generating 8.8 million pounds of thrust at liftoff. It's designed to launch the Orion spacecraft beyond low Earth orbit. Second, Orion itself, a crew capsule capable of carrying 4 astronauts to lunar orbit and back. It successfully completed an uncrewed test flight around the moon in 2022, proving the heat shield can withstand the intense temperatures of lunar return. But here's where it gets interesting. For the actual lunar landing, NASA isn't using their own lander. They're relying on SpaceX's Starship, a massive stainless steel vehicle that stands 400 feet tall and promises fully reusable access to the moon. The plan: SLS launches Orion with crew. Orion docks with Starship waiting in lunar orbit. Astronauts transfer to Starship, descend to the surface, conduct their mission, then return to Orion for the journey home. It's complex, it's ambitious, and it requires multiple launches and orbital refueling to work. China's approach is different. Instead of relying on commercial partners, they're building everything in-house through their state space agencies. The Long March 10 is their lunar heavy-lift rocket. Standing 305 feet tall, it uses a cluster of 7 YF-100K engines on the first stage, producing nearly 6 million pounds of thrust. It's specifically designed for one mission: sending humans to the moon. Next is Chang'e, their crewed spacecraft. Similar in concept to Orion, it can carry 3 taikonauts and features a reusable design that can be flown up to 10 times. The service module provides propulsion and life support, while the re-entry capsule brings the crew home. And finally, the Lanyu lunar lander, a 2-stage vehicle designed to carry 2 taikonauts from lunar orbit to the surface and back. Unlike Starship, Lanyu is purpose-built only for lunar landing, nothing else. China's mission architecture is simpler than Artemis. 2 Long March 10 rockets launch separately. One carries Chang'e with the crew. The other carries Lanyu, the lander. They rendezvous in lunar orbit. 2 taikonauts transfer to the lander, descend to the surface, then returned to Mengzhou for the trip home. No orbital refueling, no commercial partnerships, just a straightforward, proven approach that China has been testing piece by piece for years. So when exactly are these missions happening? NASA's timeline has shifted multiple times. Artemis 1, the uncrewed test flight, launched in November 2022. Success. Artemis 2, sending 4 astronauts around the moon without landing, is currently scheduled for April 2026, but it's already been delayed twice. And Artemis 3, the actual lunar landing mission, is officially planned for mid-2027. But there's a problem. Starship, the lunar lander, hasn't completed a successful orbital flight yet. It's still in testing, and it needs to demonstrate orbital refueling, something that's never been done before. Many experts now believe 2028 or even 2029 is more realistic. China's timeline is different. They announced their crewed lunar goal in July 2023, land 2 taikonauts by 2030. No earlier promises, no moving deadlines, just 2030, and they're methodically working toward it. In September 2024, they unveiled their lunar spacesuits. Lander testing began the same year. The Long March 10 rocket is scheduled for its first test flight in 2025 or 2026. An uncrewed rehearsal mission will fly in 2028 or 2029, testing the entire landing sequence without crew. Only then, if everything works, will they attempt the crewed mission in 2030. Here's the critical question. Can NASA land by 2027 before China reaches the moon in 2030? Or will technical delays push Artemis into the same time frame, turning this into a genuine photo finish? The hardware looks similar on paper: rockets, spacecraft, landers. But the engineering philosophy behind each program is fundamentally different. NASA's Artemis relies on maximum capability. The SLS is overpowered for lunar missions because it was designed to eventually send humans to Mars. Starship is reusable and massive because SpaceX wants it to carry 100 tons to the moon and beyond. It's about building infrastructure that can do more than just plant flags. China's approach is minimum viable mission. Build exactly what you need for this specific goal. Land 2 people on the moon. The Long March 10 isn't reusable because reusability adds complexity. Another major difference: propellant choice. Artemis uses liquid hydrogen and liquid oxygen for SLS, then switches to liquid methane and oxygen for Starship. Different fuels, different storage requirements, different complexity. China uses kerosene and liquid oxygen for Long March 10, hypergolic propellants for Lanyu. Simpler, more stable, proven technology. And then there's the political dimension. NASA must work with Congress, justify budgets annually, and navigate changing administrations. The Artemis program has survived 3 different presidents, but that means compromises and delays. China's space program answers to one entity, the central government. Their 5-year plans don't change with elections. Once approved, the budget is guaranteed. That institutional stability is a hidden advantage that doesn't show up in rocket specs. Why are both nations targeting the same spot, the lunar South Pole? The answer is water ice. For decades, scientists suspected it existed in the permanently shadowed craters near the poles. In 2009, NASA's L-Cross mission confirmed it. Billions of tons of frozen water, hiding in craters that haven't seen sunlight in billions of years. This isn't just scientifically interesting, it's the most valuable resource in the solar system. Water means drinking water for astronauts, Water means oxygen to breathe. And most importantly, water can be split into hydrogen and oxygen, rocket fuel. A moon base with water ice doesn't need constant resupply from Earth. It becomes self-sufficient. It can refuel spacecraft heading deeper into the solar system. The South Pole becomes a gas station, a rest stop, a launch point for Mars missions and asteroid mining operations. But here's the problem. The regions with the most accessible ice are small. Crater rims that get near continuous sunlight for solar power, while the crater floors below hold the ice. There aren't many of these locations, and whoever gets there first can claim the best real estate. The Outer Space Treaty of 1967 says no nation can claim sovereignty over the moon. But it doesn't say anything about resource rights. If you build a base on a crater rim and start mining the ice below, do you own it? Can you tell others to stay away? Nobody knows. The rules haven't been written yet, and that's exactly why the race matters. Both programs face massive technical challenges. For NASA, the biggest risk is Starship. SpaceX has conducted multiple test flights, but none have achieved full orbital capability yet. The heat shield tiles keep failing during re-entry. The orbital refueling system hasn't been demonstrated, and the lunar variant of Starship needs to land vertically on uneven terrain, something the design wasn't originally built for. If Starship falls behind schedule, Artemis has no backup lander. The entire program waits. Then there's the spacesuit problem. NASA's new lunar spacesuits have been in development since 2019, but technical issues and contractor changes have pushed delivery dates repeatedly. Without working suits, astronauts can't perform moonwalks. NASA recently handed the contract to private companies, but that adds more variables. China's challenges are different. They've never sent humans beyond low Earth orbit. Their entire crewed program, from Shenzhou to Tiangong Space Station, operates below 500 kilometers altitude. A lunar mission is 400,000 kilometers away. That's 1,000 times farther. Life support systems must work for weeks, not days. Radiation shielding becomes critical. Communication delays require more autonomy. They're also developing new technology on compressed timelines. The Long March 10 is entirely new. Mengzhou is new. Lanyu is new. 3 major systems that have never flown, all needing to work perfectly on the first crewed attempt. And there's one more factor: public failure. If NASA's mission fails, it's publicly debated, investigated, and fixed. If China's mission fails, the political consequences internally are unknown. That pressure might make them more cautious, or it might make them rush. We don't know. This race isn't just about technology, it's about power. Whoever establishes the first permanent lunar base sets precedents for everyone who follows. They demonstrate what's possible. They prove their technology works, and most importantly, they begin writing the informal rules that will govern lunar activity for decades. Consider the International Space Station. Russia and America built it together during the Cold War's end. That cooperation shaped how nations work in low Earth orbit. Now we have 2 competing visions for the moon. NASA's Artemis Accords, signed by over 40 nations, emphasize transparency, resource sharing, and international cooperation. China's International Lunar Research Station, partnered with Russia and a dozen other countries, operates under different principles: state-led development, centralized control, less transparency. 2 models, 2 philosophies, and the one that succeeds first will likely define how we explore space for the rest of the century. There's also the military dimension that nobody talks about openly. Space Force monitors everything in orbit. China's space program has direct ties to their military. Both nations understand that the technology for lunar missions, orbital refueling, precision landing, is the same technology needed for military space operations. The moon isn't being militarized, but the capabilities being developed absolutely have military applications. And then there's the economic reality. Whoever controls access to lunar resources controls a multi-trillion-dollar industry. Water for fuel, helium-3 for fusion reactors, rare earth elements for technology. The nation that can extract, process, and transport these resources cheaply will dominate the space economy. Not in 50 years, in the next decade. The stakes couldn't be higher. This isn't about planting flags. It's about establishing facts on the ground that will shape the next era of human civilization. So who's going to win this race? The honest answer is we don't know yet. NASA has the technical lead right now. Artemis 2 is scheduled for 2026, which will prove the Orion capsule works for crewed lunar missions. But the Artemis 3 landing depends entirely on Starship, and that timeline is uncertain. If SpaceX can solve the re-entry and refueling challenges quickly, 2027 is possible. If not, it slips to 2028 or 2029. China's approach is slower but more methodical. They're not racing to beat a deadline. They're building toward 2030 with deliberate testing at each step. Their advantage is institutional stability and proven execution on complex missions. Their disadvantage is lack of deep space experience. What we're witnessing is something remarkable. For the first time since 1972, humans are preparing to walk on the moon again. Not one nation, two. And unlike Apollo, this isn't a sprint. It's the beginning of permanent human presence beyond Earth. The next 5 years will determine not just who gets there first, but how we explore space for the rest of this century. Will it be cooperative or competitive? Transparent or secretive? Shared resources or national control? Those questions will be answered by whoever plants boots on the lunar surface first and begins building infrastructure. One thing is certain, the moon race is happening right now, and we're all watching history unfold in real time. If you want to stay updated on both programs as they develop, make sure to subscribe to Orbital Atlas. We'll be covering every major milestone, every test flight, and every step toward that historic landing. The race back to the moon is just beginning, and you don't want to miss what happens next.